Hello everyone, welcome to this video. In this video we'll be looking at a result. Now the question here arises is when we compose two permutations together, that product, is it even or odd, or it depends either on this thing that the two permutations taken, they are even, or they are even odd, or they are odd, both odd, right? If these are the only possibilities with us, so in all the three cases the resulting permutation, whether this is an even permutation or an odd permutation. So to answer this question here, let's move forward and see the result. This theorem here tells us that if P1 is a permutation, P2 is a permutation, then the product P1 with P2, that is an even permutation. When this is there, whenever both the permutations P1 and the permutation P2, they are either both even or both of them are odd. If that is so, then the product is even. And if any one of the permutation that is an odd permutation, then this product is also an odd permutation, right? So this is the result here. So let's move forward and prove this result. So the proof is also very simple. So in this case, in the first case, we assume that the permutations P1 and P2, both of them, they are even, and we will prove that this product is also even. So let's assume that P1 and P2, they are even. If they are even, so that means they could be by the definition of even permutation, they could be decomposed into the product of 2n and 2m transpositions, correct? Where n and m, they are positive integers. So that means when you multiply or compose P1 with P2, you will have the first 2n permutations like this, right? All of them, they are 2n in number, and then we would have the permutations which are 2m in number. So that means when we have P1 and P2 with us, then this composition is basically 2n plus 2m in number, right? So this is the thing that we are saying here. So therefore each of the product P1 and P2 and P2 with P1, so they would have 2n plus 2m transpositions, right? Where you can write 2n plus 2m as 2 times of n plus m, where n plus m is another positive integer. So that means this 2n plus m, 2 times of any number that is an even integer, that we all know, right? Based on this, the product permutation P1 P2 or P2 P1, that is also an even permutation. So this proves case 1, right, where we have assumed P1 and P2 to be even permutations. Now let us move on and prove the second case. In the second case, let us assume that both P1 and P2, they are odd permutations. So we assume P1 and P2 to be odd permutations. So that means we may consider them to be decompositions, where the first one would have 2n plus 1 transpositions within it, and the second one would have 2m plus 1 transpositions within it. Why this is so? Where the n and m, they are both positive integers, right? Now why this is so? 2n plus 1 and 2m plus 1, because you know 2n, that is 2 twice of any number is even, and when you add 1 to it, that is always odd, right? So the number 2n plus 1 would be always an odd number, 2m plus 1 would always be an odd number, right? So therefore using this thing here, the product in this case P1 P2 or the product P2 P1, both of them would have the transpositions like in the previous case equal to 2n plus 1 plus 2m plus 1. So it is 2n plus 1 plus 2m plus 1. So you could add up the content, so it would be 2n plus 2m plus 1 is 2. So you can take 2 common, so it would give you m plus n plus 1, right? Where m plus n plus 1, that is another positive integer. So 2 times of any other positive integer, that is an even number, right? So that means this product here would have these many transpositions, and these are the even number of transpositions. So therefore the product P1 P2 and P2 P1, that are even permutations. In the next case, we wanted to prove that P1 P2, that is an odd permutation whenever any one of them is odd and the other one is even. So let's assume that P1 is odd and P2 is even, right? We can go through the result in either other way also. Here we have to prove that P1 P2 and P2 P1 that is an odd permutation, right? So proving the case where P2 is odd and P1 is P1 is even, P2 is odd, in that case is covered here, because we are talking about the product in both the cases, because the transpositions P1 P2 is exactly equal to the transposition P2 P1. There is the permutations, they are equal, there is no difference at all. So now here, because we are considering P1 as an odd permutation, so therefore in this case you can write this to be 2n plus 1, right? And because P2 is an even permutation, so we can write this to be 2m, right? So it would consist of 2m transposition, and the first one would consist of 2n plus 1 transpositions. So the product P1 P2 and the product P2 P1, both of them would have the product of transpositions as the sum of this one and the sum of this one. So that would be 2n plus 1 plus 2m. So when you add them, you would have 2n plus 2m plus 1, or 2 of n plus m plus 1. So twice of any number is an even number, and when you add 1 to it, so that forms an odd number. So therefore both the products have odd number of transpositions here. So therefore because this is an odd number, so therefore the products, they are odd in this case, and this is what we wanted to prove here in this theorem. So I hope you understood the result well. Well, that is it for this video. Thank you for watching.